Okay, so there have been a couple of questions on Unit 7.3. We're going to take a look at a couple of the problems from checkpoint number 1. In this section, we're going to be solving exponential equations using logarithms. So the first one we're going to look at, this is number 3 off of checkpoint number 1. We have 3 times 4 to the x plus 2 power equals 9. And the goal here obviously is to solve for x. So what you want to do is you want to take everything on that left side and you want to cancel out one number at a time until the only thing left is just x. Well, as you can imagine, based on what we've seen previously in math, we're going to start by canceling out that 3. Since that 3 is being multiplied, we're just going to divide 3 on both sides. That way it goes away on the left side. So that's going to get us down to 4 to the x plus 2 power equals 3. 9 divided by 3 is 3. Okay, from here, this is where you're hitting the new stuff. We're down to just an exponent, right? We have a base of 4 with that exponent of x plus 2, and we need to undo that. Well, the opposite of multiplying is dividing, but the opposite of an exponent is a log. So the next step that we're going to do right here is we're going to convert this whole thing into a log. Now remember, when you convert to a log, the base comes straight down, so we bring the 4 down. Everything else needs to switch sides. That's what we refer to as the log roll. So once you clear out the coefficients out in the front and you get down to just that power, the base with the exponent, that's where you're going to switch it to a logarithm. You drop the base and everything else rolls over to the other side. Now, I need to calculate this. Log base 4 of 3. You can use a calculator for this. I have an older model of calculator, so I only have use of the log button, which is a base of 10, not a base of 4. So when I type this into the calculator, I have to use the change of base formula. I have to do log of 3 divided by log of 4, because the base always goes on the bottom. All right, and that is right here, 0.79 equals x plus 2. And then obviously to get x by itself, I would just subtract 2 on both sides. Which, if I do minus 2, gets me negative 1.21, because we're supposed to round. So negative 1.21 equals x. All right, let's take a look at a similar problem that involves fractions. All right, this one is going to be example number 4 off of the checkpoint. We have 1/2 times 14 to the 2x power equals 24.5. Now, just like the last problem, you want to start by canceling out the coefficient in the very front, and you always do the opposite. Well, the opposite of 1 over 2 would be 2 over 1. So we're actually going to multiply by 2 over 1 on both sides. And the reason why this works is if you have a 2 on top and a 2 on bottom, they cancel each other out. Of course, the 1 doesn't really matter here, so that's going to be 14 to the 2x power equals, let me grab my calculator, 24.5 times 2 over 1. And keep in mind that 2 over 1 is just 2. So really it's 24.5 times 2, which gives us 49. Okay, great. So we get rid of the number out in the very front first. When you get down to just this part where you have the power, that's where you switch it to a log. The opposite of an exponent is a log. So you're going to take the base and drop that straight down into the base of your logarithm. Everything else just needs to switch sides. So we've got the 49 and then equals 2x. From here, I turn to my calculator. Everything on the left-hand side, these are just numbers that we can calculate with the calculator. So I have to do log of 49 divided by log of 14. Okay, if you have a fancy calculator, you could actually type this in the way that it's written. All right, and that's 1.47. So I've got 1.47 equals 2x. And then, of course, to get x by itself, I'm going to divide both sides by 2. So divide that answer by 2. We end up with 0.74 because we're supposed to round to 2 decimal places. So my final answer, x equals 0.74. All right, let's try number 5. So number 5 on this checkpoint is 5 times e to the x plus 7 power equals 20. Now, just like we've seen on the other problems, we know we want to get rid of that leading coefficient first. Here we're multiplying by 5, so to get rid of it, we will divide both sides by 5. That gets us e to the x plus 7 power equals 4. In this step, we want to switch to a logarithm, right? The opposite of an exponent is a log, so we're going to switch to a logarithm. You always bring that base straight down, and everything else rolls over. So the 4 comes here, the x plus 7 goes to the other side. Now, there is something special about log base e. In fact, if you use a base of e, that's not a regular log, that's actually a natural log. So I'm just going to rewrite this: natural log of 4 equals x plus 7. All right, at this point right here, I can go ahead and type this into my calculator. This is natural log of 4. There is a button for that in the calculator. So you see the regular log button directly underneath that LN. That's the natural log. So I'm going to do natural log of 4, which is 1.39, because I have to round to 2 decimal places. 1.39. 1.39 equals x plus 7. And of course, I need to move that 7 over. Get x by itself, I'm just going to subtract 7 on both sides. So 1.39 minus 7 is negative 5.61. So x equals negative 5.61, and that would be our final answer there. All right, let's try one last example. Let's take a look at number 7. Number 7, we've got 5/6 times e to the 2x minus 5 power equals 2.5. Okay, as always, we want to start by getting rid of that leading coefficient. Here we have a fraction though, and so when you always think about doing the opposite of 5/6 is 6/5. So we're actually going to multiply by 6/5 on both sides. And the reason why this works, on the left, if you have a 6 on top and a 6 on bottom, they cancel out. If you have a 5 on top and a 5 on bottom, they cancel out. So that's what makes that fraction go away. So now we have e to the 2x minus 5 power left over. And on the right-hand side, I need to multiply this. This is going to be 2.5 times 6/5, which is 3. All right, so we got rid of the number out front. The next step we know is to convert it to a logarithm. To get rid of an exponent, you use a log. And so here we're going to take the base and we drop it straight down into the base of our logarithm, and everything else is just going to roll over to the opposite side. So the 3 is going to come over here, and the 2x minus 5 is going to drop down to the opposite side. Now, we said this in the previous example as well. Log with a base of e. You never really write log with a base of e. That's a very special situation. That's what we call the natural logarithm. So I'm just going to bring all of this down, but I'm going to write it using that natural logarithm. Okay, from here I can use my calculator. I'm going to type in the natural log of 3. So this is the LN button, natural log of 3. Gives me 1.098. Let's see, that's actually going to round up. Even if we're looking at 2 decimal places, it actually just rounds up to 1.1 equals 2x minus 5. So we're just going to keep on plugging through here to get x by itself. I'm going to have to move that 5 to the other side. So I'm going to add 5. So now I've got 1.1 plus 5. That would be 6.1 equals 2x. And then last we can just divide by 2 on both sides, which if I use my calculator here, 6.1 divided by 2 gets us 3.05. So my final answer here is going to be x equals 3.05. All right, hopefully it helps to see a couple of these worked out. And now you'll be able to go back through the rest of the problems on checkpoint number 1 and be able to use these same steps to work your way through that process. I have no idea how to stop recording.